Okay, good morning, class. Right, so at this point we're looking at equations. We did the introduction now. So, let's do the sums itself. Alright. The first example, this example is on page 52. The exercise is on page 54. Okay, so this example 1 on page 52. Alright, so here we are told in example 1 that 3 less than 7 times a number is equal to 11. Find the number. So where do we start? We say let the number be x. So 3 less than 7 times a number is equal to 11. So what do we say? If we let the number be x, then there's going to be 3 less than 7 times the number. So what will this be? 3 minus 7x equals 11. You all agree with that? Or is it the other way around? It's the other way around. Because it's 3 less than. It's the other way. So it's going to be 7x minus 3 is equal to 3 less than 7. Yeah. Okay, so what do we do now? Solve for x. So it's going to be 7x is equal to 11 plus 3. 11 plus 3 is 14 divided by 7. X equal to. Alright, so let's see if it makes sense. 3 less than 7 times the number is 2. 7 times 2 is 14. 14 minus 3 is 11, which makes that good. Alright, any confusion there? No? Let's go with number 2. Am I moving too fast? Okay. Number 2 is on page 53. So here we are told that the length of the rectangle is 4 more than the width. So which one is shorter? The width. Okay, so what we do is we draw a rectangle, so the width and the length. The length of the rectangle is 4 more than the width. So which one is the smaller one? The width. So what do we say? Let the width be x. So if the width is x, people, then what is the length? The length is 4 more than the width. X plus 4. If the perimeter is 32 centimeters, the perimeter is 32 centimeters, find the length and the width. They could have also asked you, instead of finding the length and the width, they could have asked you to work out or find the dimensions, which is the same thing. Okay. People, we are told that the perimeter is 32. How do you work out the perimeter of a rectangle? 2 length plus 2 breadth. So I'm going to write here the formula. This is what you should have known. It's going to be 2 length plus 2 breadth. What's the area of a rectangle? Length times breadth. Half a base times height is the area of a triangle is. Okay. So people, if the perimeter is 32, I mean, then you're going to say 32 is equal to 2 length. What's my length? Let me first write the formula. Perimeter is equal to 2 length plus 2 breadth. So your perimeter is 32 is equal to 2 into x plus 4 plus 2 times. You see that, people? So what will that give us now? Get rid of the brackets. So 32 is equal to 2x plus 8 plus. Sweet. Now what do we do? Numbers one side. X is the other side, so it's going to be 32 minus 8 equals 2x plus 2x, which is 4x. What's 32 minus 8? Sorry? 24. So 4x is equal to 24. So x is equal to? Ever answer the question? What's the question? They want the width and the length. So what is the width? 6. Because it's centimeters, 6 centimeters. And the length is going to be 10, which is 6 plus 4, which is 10 centimeters. Okay. Okay, for those of you making a noise in the background, please stop it if you don't mind. If you are not interested in this, there are others that are. No? Is there any issues with regards to the sum? Right, number 3. A grandfather is 50 years older than his grandson. So who's going to be younger? The grandson, of course. Okay. 5 years ago, he was 6 times as old as his grandson. How old is the grandfather now? So who's younger? The grandson. So let the boy be now X years old. Or just X. Let the boy be X. So presently, the boy is X. And the grandfather would be, the grandfather is 50 years older than his grandson. So how old will the grandfather be presently? 50 plus 8. So X plus 50. Not so. So if the boy is 5 years old now, how old is the grandfather? 55. If the boy is 50 years old, the grandfather will be 100, no? If he's still alive. Okay. But you guys have to get the idea. So the boy is X, the grandfather will be X plus 50. Okay. Then it says, 5 years ago, 5 years ago, the boy and the grandfather. So if the boy is currently 8 years old, how old would the boy have been 5 years ago? X minus 5. Like, for argument's sake, if the boy was 8, then 5 years ago he would have been 3. If the boy is 30, 5 years ago the boy would have been 25. Not so. You just subtract 5. If the boy was 5 years old, 5 years ago he was 0, he was born. Not so. Right. You're not going to use 4, no? Because then you will be again not thought of yet, okay? Or you will be still swimming somewhere. But anyway, so if the grandfather is X plus 50, then how old will the grandfather have been 5 years ago? X minus X plus 50? Minus 5. You all agree with that? So it's X plus 50 minus 5, which gives you X plus 45. So hang on. 5 years ago, he was 6 times as old as his son, grandson. So the boy must be multiplied by 6 to get the grandfather's age. Again, 5 years ago, which is this year, 5 years ago, he was 6 times as old as the grandson, which means to say whatever the grandson's age was 5 years ago, I must multiply it by 6 to get his age now. Okay. The question says, how old is the grandfather now? So when I solve for x, I will actually get the boy's age. Not so. Then I must add 50 together, grandfather. But anyway, let's solve the sum. So you say 6 times, what's the boy's age 5 years ago? X minus. You all understand why I'm using x minus 5 and not x? Why am I using x minus 5? So that was 5 years ago. Okay. 5 years ago the boy was x minus 5 is equal to the grandfather's age 5 years ago, which is x plus 45. And people, it's easy. Once I got this part out, the rest is child's play. No? 6 times x is 6x minus 30 is equal to x plus 45. X is one side, numbers the other side. So it's 6x minus x is equal to 45 plus 30, which is 5x is equal to 75. 75 divided by 5, which is 1 carried to 15 years. Who is 15 years old? The boy is 15 years old. Why are you guys getting shy? So you guys are 15. Oh, okay. The right age for you, Pumla. Huh? Right, but anyway, so the people presently, the boy is 15 years old. And the grandfather? Grandfather is going to be presently x plus 50, which makes the grandfather 15 plus 50, which is 65 years. Okay. The rera gaan open. People see any confusion there? Easy, no? It's easy if you see somebody else do it. Yes. People, let's look at example 4. It sounds beautiful, no? Especially if you get it right, but when you're getting it wrong, you don't want to say it's beautiful. People, number 4. Number 3. A batsman scored 72 runs. You guys watch cricket? No. Oh my word. Okay, I also don't watch cricket anymore. Right, the batsman scored 72 runs of 4s and 6s and singles. Okay. So what happens is the guy runs, everybody's watching him, and he throws the ball at the batsman. You call it bowling. You guys call bowling something else, no? Yeah. Yes, I know. Alright, so, and he hits the ball, he has a chance of running singles. He can run 1, 2, 3 or 4 singles, depends on how far the ball is from where he is. Or if he hits the ball over the ropes without touching the ground, that is worth 6 runs. And if he hit the ball and he touches the ground before he hits the ropes, it's 4 runs. Okay, that's the crux of the scoring process. Okay, there is more, but that is what is dealing with here. Okay. The batsman scored 72 runs of 4s, 6s and singles. Okay. He hits an equal amount of 4s and 6s. Okay. And twice as many singles as 4s. How many of each did he hit? Okay. Remember, when I add all the 4s and all the 6s runs and all the single runs, it comes out to 72. So where do you think we're going to start? We're going to say let the 4s and 6s be x. Why am I going to let the 4s and 6s be x? Because he hits the equal amount of 4s and 6s. You guys see that? So if he hits, say for argument's sake, he hits only 1 4, then what would his score be? 4 runs. No? What if he hits 2 4s? Only 2 4s. He's going to get 8 runs. Because 2 times 4 is 8 runs. He's a very good batsman. And he hits 6 4s. How many runs would he have? 24. Now what if we had two sixes and 3 fours and 1 single? Okay, that's not normal, no? But okay. The single is normally the most. But okay, he's a different kind of batsman. He had 3 fours, 2 sixes and 1 single. How many runs in total would he have? So 3 fours would give you how many runs? 12. 2 sixes? 12 and 1 single? 1. If added, it gives you 20. So you get the idea how they get 72. No? Somehow. In this line of, what's the name of thought here? So if you look at the fours, the total that's coming with the fours, whatever amount of fours he hits, how many, or how would you work out the total runs of fours that would have been contributed to 72? It will be 4 times x is equal to 4x. You all agree with that? So look at it this way. If we had hit 1 4, 1 times 4 is 4. If we had hit 3 fours, 3 times 4 would have given you 12. 4 fours, 16. Well, how do we get that? 4 times whatever amount of fours he hits. So if I set up the equation for sixes, what would that be? I was going to get that. 6x. Singles? Now we come to the singles, we are told he hit twice as many singles as fours. How many fours did he hit? How many fours did he hit? X amount of fours. If we hit twice as many singles, it's going to be 2x. Okay. Remember, how did we get the total? We added the story up. Not so. Then we do the same here. It's going to be 4x plus 6x plus 2x is equal to 72. So 4 plus 6 is 10 is 12. 12x is equal to 72. Divided by 12 both sides. So x is equal to 6. So what does that mean? Therefore, how many fours did he hit? 4 times 6, which is, sorry. How many sixes did he hit? 6 sixes and 6 fours as well. Why? Because sixes and fours is equal to x. So he hit 6 sixes, 6 fours, and how many singles did he hit? Twice this amount, which is 12 singles. Okay, and we can test. 6 times 6 is 36 plus, whoops, 6 times 6 is 36 plus 6 times 4, which is 24 plus 12, should give me an answer, 72. Okay. Imagine you get the sum in the exam. 5 marks. Why are you saying? Imagine if the same sum comes in. Would you get it right? Oh man. How can you say no? What's wrong with you guys? Alright. People. Yes? I thought you were going to ask you something mathematical. Make it. What's this guy's name? Zucchini. Okay. So here we are told that Zucchini walks at 4 kilometers per hour and runs at 6 kilometers per hour. Something wrong with Zucchini. No? We don't do those things. No, that's why we look as we look today. We should start being like Zucchini. Okay. But anyway, Zucchini walks for 4 kilometers per hour, he runs 6 kilometers per hour. If he runs all the way, he reaches the station 15 minutes earlier. Find the distance to the station. if he knows exactly how many kilometers per hour he's running, the speed, and the kilometers he's walking, of course, finding the distance should have been easier, no? But okay, this is the sum. People, I find this to be the easier of the two. No? I draw a table when it comes to speed, distance, time. So we've got speed, distance, time. So he walks and he runs. He walks 4 kilometers per hour, so that's the speed. He runs 6 kilometers per hour. If he runs all the way, he reaches the station 15 minutes earlier. Okay, so what do you think we're going to let be x here? The question says find the distance to the station. So what do I say? Let x be the distance to the station. Not so. Let x be the distance. So what's going to go here? X. So if he walks to the station, he's covering x kilometers. Not so. If he runs to the station, will the distance be shorter or longer? Talk nonsense, man. The same is. How can it be shorter? The time will be less here. The time will be shorter. But the distance will remain the distance. You guys can't see, so you're tired already. But anyway, that is x. Alright, then we draw this triangle here. What goes on top? D. And here? ST. We won't say how we remember that, no? Why must D be on top? Alright. Not D. Not the O, it's a D. Alright. But anyway, so now we want to work out the time in terms of x and 4. So what is the time that it takes if he walks? So I close T. So it's going to be D over S. So what's your distance here? X over 4. You all agree with that? You work out the time that he runs. So it's going to be x over. Okay. So we read the question again. If he runs all the way, he reaches the station 15 minutes earlier. 15 minutes earlier. But hang on, we're speaking about kilometers per hour. So 15 minutes is how many in an hour? 15 over 60, which is a quarter of an hour. Okay. So, the time that he runs, will that be longer or shorter than the time the time he walks, will that be longer or shorter than the time he runs? Longer. So it will be the bigger time minus the smaller time would give me an answer of a quarter. Again, if you read here, if he runs all the way, he reaches the station 15 minutes earlier. So which means to say that the difference between the time he walks to the time he runs, that difference is a quarter of an hour. You guys understand? And from here, it is just exercise 3 and 4 coming into play. What is your LCM here? 12. So this must be multiplied by 3. This must multiply by 2. This multiply by 3. So it's going to be 3 into x minus 2 into x equals 3 into 1. Right, so 3 times x is 3x minus 2 is equal to 3. So x is equal to 3. But what does this represent? Let x be the distance. So therefore, it will be 3 kilometers. Find the distance of the station, it's 3 kilometers. Easy, no? What do they ask you to calculate? The time. The time it takes to walk. So it will be 3 over 4. So that is 3/4 of an hour, which is 45 minutes. you calculate the time he runs, will be 3/6, which is half an hour, or 30 minutes. But this wasn't asked. Okay. People, if I'm you, I would spend some time on this. Okay. For homework, as I said, I'm going to break this up so that we can do each and every sum of this exercise. We will do the recording of that as well. For tomorrow, there are 20 sums. How many are you going to do? 10. No, 10 is too much. Okay. 7. 7 is a good number. Okay. So we're going to do we're going to break it up into 7, 7 and 6, which give you 20. Remember the combination, 7, 7, 6. Yeah. So tomorrow, numbers 1 to 7. And we'll start our graphs as well tomorrow. People enjoy the rest of your day. Good afternoon, class. The full lesson can be found in the description box below.